Hey guys, we're going to do a cone problem for related rates. For cone problems, generally you need to do a little bit extra side work in order to be able to set up your problem effectively. So let's start out by reading the problem. We've got a conical paper cup. This is a cone. It is 3 inches across the top and 4 inches deep, is full of water. The cup springs a leak at the bottom and loses water at a constant rate of 2 cubic inches per minute. How fast is the water level dropping at the instant the water is 3 inches deep? And then the second question is, how fast is the radius of the cup changing when the water level is 2 inches? Okay. So water level is the height of the water. The water is a cone shape, just like the cup is a cone shape. Let's use blue for the height of the water. And let's use pink for the radius of the cone. Okay, and then you've got the water that is filling up the paper cup. So it's all down there at the bottom. So radius is pink and height is blue. I'm drawing just a right triangle, just like the radius and the height of our cup made a right triangle. We are told that the paper cup is 3 inches across. That means that the radius of the top of the cup is 1.5. And the height of the whole paper cup is 4. Okay. So as we talk about any water level and any water that's in the cup, this triangle is going to be in proportion to any other right triangle that we are going to see. So instead of R and H, we have this ratio of 1.5 to 4. Let's make a proportion out of it. If we've got a radius and it's 1.5, and we've got a height and it's 4, we could solve to get either H by itself or R by itself, and then we can substitute that out of our problem. Of course, we don't have a problem yet. We need to figure out some kind of a formula to go along with our picture. Okay, but we know that this equation is true. So you can either put R over 1.5 and H over 4, or you can put R and 1.5 on top and H and 4 on the bottom. So it could have been R 1.5, H 4, like that. Okay, either one of those proportions is the same thing. Sometimes you'll have to solve to get R by itself. Sometimes you have to get H by itself. So let's figure out what information we have. We have the volume of a cone. That is something that's very important to this. How fast is the water level dropping? So R and H work really well in this formula. V equals 1/3 pi R squared H. That's the volume of a cone formula. We know that we have to take the derivative with respect to time. So this will be dV dt equals, oh yikes, this is the, we got an issue here. We have a product. We don't want to deal with the product rule if we can help it. Let's see if we can rearrange some stuff to either get rid of R's or get rid of H's. Okay. What information do we have? We have that the cup is leaking water at a rate of 2 cubic inches per minute. All right, so off to the side, let's do some stuff. V equals, R equals, H equals, and dV dt equals, dr dt equals, dH dt equals. We are only allowed to have one unknown variable in this derivative, only one. including the rates. So what do we have? We know that the cup is leaking at a rate of 2 cubic inches per minute. Cubic inches is a volume, but per minute means that it's a rate of the volume. 2 inches cubed per minute. However, this is losing water, so it is a negative rate. We could figure out V. However, when you take the derivative of V, V is going to disappear, so we don't care. Because we don't need to plug it in. You could totally solve for it. How fast is the water level dropping at the instant the water is 3 inches deep? Okay, so deep is a height. That is 3. How fast is the water level dropping? That's this right here. We don't know, but it's inches per minute since height is measured in inches and time is measured in minutes. We know that the water level is dropping, so we expect dHdt to be a negative number. Now, we don't know the radius, but we could figure out the radius using this right here. Or we could just get rid of this somehow. We know that the radius is the same thing as, let's see, we can solve this to get r by itself. So let's multiply using the fish method. 1.5 times h divided by 4 is r, or you could do cross multiply and then solve for r. There's lots of ways to do it. So r is going to equal 1.5 h over 4. And we can simplify that out using a calculator. 1.5 over 4 is going to be the same thing as 3/8, and then just put the h next to it. So we are not going to need dr dt as long as we can get r in terms of h. So I'm going to get rid of this dv dt thing over here on the left. We're just going to get rid of r, replace it with something that has h's instead, which is 3/8 h. So pi over 3 times something squared times h, and r is 3/8 h. Or 3h over 8, it's the same thing. Okay, squaring. So we're still not taking the derivative because we got to make this look nicer. We want h to be to the 3rd power, but we can't get there yet. We have to multiply top times top and bottom times bottom. So this is pi over 3, which we already have. 3/8, 3 times 3 is 9. 8 times 8 is 64. And h times h is h squared. And then times the h that was already there. Okay. Simplifying this fraction out, the 9 and the 3 are going to partially simplify. It ends up being v equals 3 pi over 64. And then over here, h squared times h is h cubed. All right. Now that all we have are v's and h's, we don't have to worry about r or dr dt. We can just kind of get rid of that. Let's take a derivative of the left and of the right with respect to t. So that's dv dt equals 3 times 3 pi over 64 is 9 pi over 64, h squared. But then we have to multiply times dh dt because of that chain rule bit. Okay, the only thing we don't know is dh dt. We've got h and we've got dv dt. So this is -2 equals 9 pi over 64 times h is 3, so 3 squared, times dh dt. Simplifying, 3 squared is 9. 9 times 9 is 81. So we got -2 equals 81 pi over 64 dh dt. We're going to multiply by 64 and divide by 81 pi, or multiply by the reciprocal on both sides. So choices on how you want to write it. So this ends up being -128 over 81 pi, which is kind of gross, equals dh dt. So this is an exact value. We got it by multiplying, change colors. We multiply by 64 over 81 pi. Times 64 over 81 pi, because this cancels that. All right, we expected dH/dt to be a negative number, so this is good. If it's not a negative number, then probably we just missed a negative somewhere else, which was likely right here, plugging in a positive instead of a negative. All right, dH/dt, let's get a decimal approximation, is about negative 0.503. H is measured in inches, time is measured in minutes. So the change in height is negative 0.503 inches per minute. It's a rate of change of the height. We have a second question. The second question is, how fast is the radius changing when the water level is 2 inches? Water level, again, is a height. So how fast is the radius of the cup changing when the water level is 2 inches? We know we either have to get rid of R or H. So usually these will be two completely separate problems. So in this case, H is 2, but if H is 2, using, triangles, we can figure out that this triangle is twice as big as the one that we're looking at. So the triangle would be 2, and then what is 1.5 divided by 2? That is 0.75. So the radius is 0.75 when the height is 2, using similar triangles. All right. So the volume still has dV/dt equals -2. R is 0.75, and we want to know what is dR/dt. Okay. The issue is that we have to go back to our original formula, and we have to get rid of H this time. That means we need to get H by itself from over here. So this is going to be kind of the opposite. Instead of doing R is 1.5 times H divided by 4, we are going to solve to get H by itself. So 4 times R divided by 1.5. So H is going to equal 4R over 1.5, which ends up equaling 8 pi over 3. Wait, where did I get pi from? 8 over 3. 8 R over 3. Okay, multiplying top and bottom by 2 gets rid of that decimal is really what happened there. So H equals 8R over 3. Okay, let's replace H with 8R over 3. So it's going to replace that. V equals pi over 3 times R squared times 8R over 3. Multiplying top times top and bottom times bottom, we get 8 pi over 9 times R squared times R is R cubed. All right, now we can take our derivative, since we only have the variables that we can do something with, the ones that we have numbers for. Left side dV/dt equals right side 3 times this fraction, ends up partially canceling with that 9, so it's 8 pi over 3 times R squared times derivative of R dR/dt. And now we can plug in as much information as we have. dV/dt is still -2 equals 8 pi over 3 times R. We are told that at this instant, the water level was 2, so our radius was 0.75. 0.75 squared times dR/dt. All right. So square the 0.75, multiply it over here. Okay, 0.75 is 3/4, so squared is 9 over 16. 8 pi over 3 times 9 over 16 dR/dt Was that -2? 8 and the 16 will partially cancel. So we get an 8 on the bottom. 3 and 9 will partially cancel, so we got a 3 on the top. All right, 3 pi over 2 dRdt. Multiply left and right by the reciprocal of that, so times 2 over 3 pi times 2 over 3 pi. So we have -4 over 3 pi for dRdt. -4 over 3 pi. Okay, so dRdt is about -0.424, radius measured in inches, time measured in minutes.